Hello and welcome to my sliding ladder project. I am your host, Taylor Tweeden. I am going to be telling you about how a ladder slides down a wall. First off, we used 3 meter sticks to do this exercise. We positioned 2 meter sticks perpendicular to each other, one laying on the floor with its end at 0 centimeters against a wall, and the other on top of the other meter stick, starting with the base at 0 centimeters and held it straight up on the wall. The third meter stick was used as the ladder. We moved the ladder a certain distance away from the wall and then measured how far the ladder slid down the wall. Now that you know the process, let's jump right in. First, we started with the ladder 0 centimeters away from the wall. The distance that the ladder moved down the wall was 0 centimeters. Then, we moved the ladder 10 centimeters away from the wall, and the ladder moved 0.8 centimeters down the wall. Next, we moved the ladder 20 centimeters away from the wall, and the ladder moved 1.8 centimeters down the wall. Next, we moved the ladder 30 centimeters away from the wall, and the ladder moved 2.9 centimeters down the wall. Next, we moved the ladder 40 centimeters away from the wall, and the ladder moved 4.3 centimeters down the wall. Next, we moved the ladder 50 centimeters away from the wall, and the ladder moved 5.6 centimeters down the wall. Again, we moved the ladder 60 centimeters away from the wall, and the ladder moved 7.6 centimeters down the wall. And you guessed it, we moved the ladder 70 centimeters away from the wall, and the ladder moved 10.5 centimeters down the wall. We then moved the ladder 80 centimeters away from the wall, and the ladder moved 14.5 centimeters down the wall. And lastly, we moved the ladder 90 centimeters away from the wall, and the ladder moved 27.6 centimeters down the wall. This is our data chart. Below the data chart is the equation we were given to make our graph on Desmos. The data on the left in black, which is right here, was our original data. However, that data is wrong because those were just the measurements of where the ladder was on the wall meter stick. For example, when our ladder was at 0 centimeters away from the wall, we measured that it was 8.6 centimeters, which is right here, which was where the ladder was located on the meter stick that was representing the wall. The data to the left in pink, which is right here, is the actual correct data we should have gotten. I got this data by subtracting the original ladder locations by the new ladder locations. For example, I subtracted 8.6 from 9.4 to get 0.8, which was the distance the ladder slid from the original location, which was 8.6 to 9.4. Because we used the wrong data to make our equation, the graph is wrong, but I will show you what it looks like anyway. This is the equation. Here's our graph. Just imagine that the points are right and it would basically look the same, with an upward trend just like this. I included a graph with the correct data points, which if the correct equation was plugged into it, it would have a slope like this going through it. What I learned from this project. Make sure to triple check your data to make sure that you didn't make silly mistakes. I hope you enjoyed this podcast. Thanks for listening. This is Taylor signing off.